So let's take a look at finding the least common multiple of two numbers. So this is going to be the smallest number that both of the numbers can multiply up to. We're going to go through two methods here. Both are equally effective. They both find the numbers the same. Sometimes one way can be more efficient, so it might be faster with one versus the other, but it just kind of comes down to which one you like better. So with the first method, this is where we're just going to list out multiples of each number, and then we'll look for where they match up. So what this means, if we're looking for the least common multiple of 4 and 6, then what I'm going to do is start listing out multiples. So with 4, there's 4 itself, and then times 2 is 8, times 3 is 12, times 4, times 5, times 6, times 7, times 8, times 9, times 10. Let's go that far. And let's do the same for 6. So times 1, times 2, 3, 4, 5, 6, 7, 8, 9, 10. Really hard to read out a different number that I'm writing down. Okay, so now what we're going to do is look through the list and find the smallest number that shows up in both lists. And we hit it pretty early on with 12, so I didn't need to go that far. But just to kind of show you that maybe sometimes you would have to go out that far. Really, no matter what, you should be able to stop at these two numbers multiplied. So like 4 times 6 is 24. That would be the largest possibility, if that makes sense. But then anything smaller is actually preferred. So what I could have done here is stopped at 24, knowing that that's the two numbers multiplied together. So 12 is the least common multiple. So let's do that with 3 and 5. Now with 3 and 5, what I could do is know, okay, I only need to go up to 15. So 3 times 1, times 2, times 3, times 4, times 5. We're done. And then 5 times 1, 2, 3. So what I would be looking for is anything smaller that matches up, but there isn't. So 5 would be our least common multiple. Sorry, 15 would be our least common multiple. Now, another way that we can do this here that might be a little bit faster is instead of listing for both of them, say I just start with the largest one. So 12 times 1, 2, 3, 4, 5. What I'm doing is listing these until I reach something that's divisible by 8. And actually, I've already done it. So like 24 is divisible by 8. So that's going to be it. So what I could do is, when I'm working on this list, just each number that I write down, check if 8's divisible. So like 36 doesn't work, 48 would work, 60 doesn't work. But it saves me a little time. Instead of writing out the list for the values of 8, start with the larger number and just list out values until it's divisible by the other. But that works great. Or we could have done listing out 8 as well. 1, 2, 3, 4, 5, and so on. But we could stop when we hit 24. So with that, another way kind of within that method of you could just start listing out the larger of the numbers and stop when it's divisible by the other value. Okay. Another way of doing this is with prime factorization. So what we're going to do is write the prime factorization for each number and then use the highest exponent for each prime factor. So what this looks like, if we're doing 4 and 6, So prime factorization of 4 is just 2 and 2. So that's 2 squared. For 6, it's going to be a 2 and 3. So we have a 2 times 3. So putting together my least common multiple, what I'm going to do is first just evaluate the bases. So let me kind of split this up a little bit. So with 4, we just have a base factor of 2. With 6, we have a base factor of 2 and 3. So putting together my least common multiple, I'm going to grab kind of my unique base factors. So we're going to have a 2 and a 3. So that's part of it. What I still need to fill in the blank for are exponents. And what we're going to do is use the highest exponent of each prime factor. So we have an exponent of 2, and then over here we technically have an exponent of 1 for each of those. So the largest exponent for 2 is a 2. So we're going to use that. 3 has the largest exponent of 1. So we're just going to keep that as is. And that's it. So 4 times 3, which is 12, which we found up above there by making the list. But we could use the prime factorization. Now, explaining that out took a really long time, but it can get a little faster as we get a little more comfortable with our prime factorizations. So let's go through a few more examples here, and this really shows that this method can be much better for large values where it could be difficult to list out the multiples, and also like if you think about how the largest one would be 36 times 54, that would take such a long time to make that list. So really prime factorization is the best way to go here. So 36 comes from a 6 times 6, which is a 2 and 3, 2 and 3. So we have 2 squared times 3 squared. All right, that's one of ours. And then 54, I know, is divisible by a 6 and 9, which is a 2 and 3 with a 3 and 3. So that is a 2 times 3 cubed. Okay, putting together my least common multiple. First thing I'm going to do is grab bases. So we have a base of 2, base of 3. Over here we also have a base of 2, base of 3. So my unique bases, base of 2, base of 3. Now I'm just going to fill in the little exponent of 1 there. So I want to grab the largest exponent. So 2 has an exponent of 2 or 1. So we want to use that exponent of 2 because it is larger. And then with 3, we have an exponent of 2 or an exponent of 3. So we want to use, sorry, my pen keeps changing on me. We want to use that exponent of 3 because it's larger. And then just a quick double check. That's a 4, that's a 27. And just quickly in a calculator, plugging that in, 4 times 27. So 108. And I would just make sure, can I divide that by 36? Yep, 36 times 3 is 108. Can I divide 108 by 54? Yep, 2 times 54 is 108. So that is our least common multiple there. All right, one more example here. 60 and 72. All right, so we have a 10 and 6, which is 2, 5, 2, and 3. So we have 2 squared times 1, 3 times 1, 5. All right. Then 72 can be divided up by a 9 and 8. 9 is divisible by 3 and 3. 8, 2 and 4, which 4 is a 2 and 2. So this one we have 2 cubed times 3 squared. Okay, putting together least common multiple. Looking at the bases, we have base of 2, base of 3, base of 5. Over here we have 2 repeated, 3 repeated. So for the least common multiple, I want 2, 3, and 5 for the bases. Then I'm going to grab the largest exponent. So 2, it's an exponent of 2 versus 3. So we want to use the 3. With 3's, it's 1 versus 2. So we want to use the 2. And then for 5, there's only one possibility there with the 1. So we'd have just 1 5 there. And that would be the prime factorization for our least common multiple. And actually, realizing we should be multiplying these out so that we can see the actual numbers. So let's see, 2 cubed times 3 squared times 5 is 360. And then we could see, does 60 divide into that? Yep. Does 72 divide into that? Yep. So we're all good. And let's just finish these up by having the actual number. That was 108. And this one, 4 times 3, which was 12. So, okay, least common multiples. This is going to be helpful, especially when we work with fractions and rational expressions. So we'll want to get used to finding the least common multiple between two values, but then it can be a choice of which method do you like best.